Okay, so here we need to explain the concept of the direction angles, direction cosines, and direction ratios of a straight line in space. So if we have a straight line in the space, suppose this is the line L1, and this is the, suppose, x-axis, this is suppose the y-axis, and this is suppose the z-axis. So then suppose the straight line L1 makes an angle alpha with the x-axis and beta with the positive y-axis. So it makes alpha with the positive x-axis and angle beta with the positive y-axis and angle gamma with the positive z-axis. Then the angles, alpha, beta, and gamma are called the direction angles. These are called the direction angles of the line L1. And cos alpha, cos beta, and cos gamma are called the direction cosines. Called the direction cosines of this line L1. So this cos alpha is also written as L. L is cos alpha and M is cos beta and N is cos gamma. And in L square plus M square equal to 1. So this L, M, and N are called the direction cosines, and the sum of the squares of the direction cosines will be 1. We can prove this by taking that, suppose this the line L1 is parallel to some vector B1, suppose, then the vector B1, if it is written as A I cap plus B j cap plus C k cap, then A, B, and C are called the direction ratios. A, B, and C are called the direction ratios of the line L1. And um, then B1 cap, the unit vector along the B1 vector, that can be written as Li cap plus Mj cap plus Nk cap, where L, which is cos alpha, that can be written as A by magnitude of B1 vectors. So it will be A by square root of A square plus B square plus C square, and M, that is cos beta, that will be equal to B by square root of A square plus B square plus C square, and N, which is cos gamma. So that will be equal to c by square root of a square plus b square plus c square. So therefore we can see that cos square alpha plus cos square beta plus cos square gamma, cos square gamma, sorry, cos square gamma, that will be equal to 1. It means L square plus m square plus n square, that will be equal to 1. So the sum of the squares of the direction cosines is 1. So therefore the rule is that if L, m and n are the direction cosines of a line, then the unit vector the unit vector parallel to the unit vector parallel to that line is Li cap plus mj cap plus nk cap, and uh, uh, and any set of three numbers which is proportional to any set of three numbers that are proportional to the direction cosines. The direction cosines are the direction ratios, are called the direction ratios of that line, So it means that uh, a vector that is parallel to a line L1, a vector that is parallel to a line L1 is given as k L I cap plus k m j cap plus k n k cap, where k is some constant, and that can be also written as ai cap plus bj cap plus ck cap. Then so a b c, or we can tell that kl, km and kn are the direction ratios of the line, are the direction ratios of that line, and L, M and N are the direction cosines of the line. And the sum of the squares of the direction cosines, that should be 1. So we can understand this by using one example. Suppose, for example, if it is asked that that if a line has direction ratios, if a line has direction ratios 2, -1, -2, then then de- determine then determine its direction ratios. Determine its direction ratios. No, sorry. Determine its direction cosines. Okay. So then Here- Therefore, we can say that the direction cosines will be, so here the rule is, so here we have to actually apply the rule is that if A, B, and C are the direction ratios of the line, are the direction ratios of the line, then its direction cosines will be, its direction cosines are given as A by square root of A square plus B square plus C square, comma, B by square root of A square plus B square plus C square, and C by square root of A square plus B square plus C square, where this A by square root of A square plus B square plus C square, this will be L, and this will be, this B by square root of A square plus B square plus C square is M, and this is N. So L, M, and N. So the direction cosines of the line are L, M, N, where L will be equal to 2 by square root of 2 square plus minus 1 whole square plus minus 2 whole square. So that will be equal to 2 by square root of 4 plus 4 plus 1. So that is 2 by, this is square root of 9, that is 3. And M, that will be equal to minus 1 by square root of 2 square plus minus 1 whole square plus minus 2 whole square. So that would be minus 1 by 3. And N would be equal to minus 2 by square root of 2 square plus minus 1 whole square plus minus 2 whole square. So that would be equal to minus 2 by 3. So hence the direction cosines of the line will be, the direction cosines of the line will be equal to 2 by 3, comma, minus 1 by 3 and minus 2 by 3. Thank you.